yours. Okay, so we're going to talk about functions and their graphs. So first of all, a function is a rule, an operation, a series of operations that basically has one value in the range for every value in the domain. All right? The notation that we use for functions is this, right? And you know by now that f of x and y are interchangeable. When we talk about domain, right, we often call it, refer to it as D, capital D. And range, we often refer to it as capital R, all right? And you already know domain and range. Domain are the values that go into a function. Range are the values that the function generates, given those domain values, okay? So, take a look here. You have your domain, right? And for each of the values in the domain, there is one value in the range. This value in the domain has one value in the range. This value in the domain has one value in the range. This is a function. But here, this value in the domain has two values in the range. This is not a function. Okay? So if you put x equals 3 into a function, you should only get one y equals 1. If you put x equals 3 into a function and you get y equals 1 and negative 1, that's not a function. Okay?
So for every domain, that's you.
For each domain, there has to be one value in the range. Okay, so a little bit about notation, set notation, and interval notation. So you guys are already used to interval notation, right? Anybody not used to this? This is calculus notation. In calculus, we rarely use the inequalities. We use this mostly in algebra. We rarely use it in calculus. All right?
Is this easier?
It's more compact, right? Because it's like, instead of doing all this, you could just do A to B, and if it's parentheses, then the A and the B are not included. It's open circles, right? So if you guys have any questions on that, you can come and tell me. Does anybody have any questions on this, or can we move past? Okay. Okay. Everybody's favorite. Let's do domain and range. Okay. All right. Domain and range and sketching the graph. So in calculus, the expectation is that if you see a function, you should know what kind of graph it generates. Like if you see number 1, you should know that it's a parabola facing down, right? If you see part A, or if you see like a cubic function and so on. So here, like we said, you can rewrite it like this, negative x squared plus 2. Right? This is the way you've seen it more, right, previously. So this is a parabola facing down. The vertex is at 0, 2, right? And then what we want to do here is we want to do a sketch, right? We're not going to bother with like too many details. We just want to do a sketch. So if you just pick one of the points here, right, at x equals 1, what's the y value here? 1. And then we mirror on the other side. And this is a good enough sketch for the purposes of calculus. Okay? Like doing one like this, I wouldn't be okay with, right? That's too wide. But, it's also like not NASA precise, right? So
you said put 1 in x?
So yeah, so we know that this is the vertex, and then I just put in, like, for example, x equals 1. I put it in the equation, and that gave me y equals 1, and then I mirrored it. Okay, let's talk about domain. here's how I need you guys to approach domain. When you look at this function, this is a polynomial function. There are no square roots, there are no fractions. The domain is all reals, right? So we say the domain is negative infinity to positive infinity. Okay, last year, there was a lot of tendency, and this is very common in pre-calculus, to switch the order of the negative and positive infinity. And sometimes, you know, we were like, okay, let's just let them slide. No more in calculus. That cannot happen anymore in calculus. When you have interval notation, you have to make sure that the lower valued number is on the left and the higher valued number is on the right. Negative infinity is a lower valued number. That goes first, then this one, okay? Okay, and then the range, it's probably easier to see when you graph. It goes from negative infinity to 2. So if a student put 2 to negative infinity, that's not going to be full credit. Yeah. Yes, sorry. I'm so sorry. This one is a full bracket. Thank you. Okay? Thank you. Yeah, that is. Okay. 1 over x. 1 over x is a rational function. Are there any asymptotes here?
No. Yes.
Yes, at 2. Oh, at y equals 2.
For B?
Oh,
We're at B.
A,
We're at B. A doesn't have any asymptotes. Is there a vertical asymptote? Where?
0. No, positive.
X equals 0 is a vertical asymptote. How do we do vertical asymptotes? Set the denominator equal to 0.
Oh, and
that's
the other
right.
one is
My instinct was right.
Okay? To do asymptotes, you set the denominator equal to 0. Okay? And x equals 0 here, so you have a vertical and a horizontal asymptote.
Where's the horizontal?
Okay. The other problem doesn't have a denominator. Okay.
Why do you do the vertical asymptote?
Vertical asymptote only comes.
Because it has, okay, so this gives you a vertical asymptote. Okay, and there's also a horizontal asymptote. So now, as we go through this, I'm going to show you the ones that you can use a calculator on to graph and the ones that you should know without a calculator. This is one that you can use a calculator to graph. Okay? So, when you graph this, it will look like this and like this. Okay? Yeah.
Sorry, how did we get the horizontal asymptote?
So I didn't go over. I'm gonna have you guys do it on the graph. Yeah. Okay.
So for this one, we don't have to find certain points.
Correct.
Why not?
Because you're just doing it on the calculator. Yeah.
Will you tell us which ones you need to
Right there. Yeah, I put calc right next to it. B. Yeah. So the domain here. Okay. The domain. You have negative infinity to 0, and then 0 to positive infinity. The only place that there is a break is at 0. So negative infinity to 0, 0 to infinity. The range, negative infinity to 0, there is a break at 0, and then 0 to infinity.
Can you just remind me how we know that there's a asymptote along the y-axis?
So you're graphing this, right? So what you learned last year in pre-calc is, whenever there is a fraction, you can set the denominator equal to 0, and that value gives you the vertical asymptote.
Right.
But this particular problem, you can also graph it, and on the graphing calculator, it'll tell you that there is an asymptote here and here. Okay? Yeah.
For this sketching, for the
Uh-huh.
where it's like this, do you need any specific points?
No. Okay. What kind of graph does this one? It's a,
Oh, it's one of the
Right? Yup, exactly. Okay, so where is the endpoint here? What does the 3 do? Move it where? Up. What does the 4 do? Move it where? But where? Right or left? Left. So we're at -4, comma 3.
I have a question.
Yeah.
Are we gonna have to write like trend like with the if there's like
No.
Yeah.
And it looks like this. Okay? You can put the arrow, or you don't have to put the arrow, it's fine. No. Just know what it looks like because we're just doing it for domain and range.
Yeah, but how do I know it's going that way, not that way?
Well, that's what you learned last year.
Because it's in the part of the like.
You know what else you can do? You know this point. Just put in the point next to it. See, okay?
Does that based off the 3 window? Oh no, if the 2 is negative, it would go down.
Right.
Oh.
Okay, so now, domain.
Do we not get asymptotes with this?
No. Only asymptotes if it has a rational, like if it has a denominator. Okay, domain. It starts at -4, goes to infinity, and it starts at 3 for the range and goes to infinity. Okay. This problem for now is definitely calculator. In chapter 4, 5, you're gonna know exactly what this looks like for the rest of your life, okay? This is a semicircle, okay? And it goes from, it's like a radius of 3. You're gonna graph it. You don't have to know. We're only doing this to figure out domain and range right now. This is if you graph it, we're gonna pretend we graphed it on the calculator. That's what it looks like, okay? No, that's why we're just doing this right now for you to be able to look at the graph and figure out what domain and range is. So the point of this is that versus the graphing, okay?
I have a question about C really quickly.
Yeah.
I know for the sketch for A, we had to plug in an exponent. Do you want us to do that to have a point
For C?
for C?
No, just do a rough sketch because it's not gonna like affect the domain and
So
stuff.
when do we know when to add a point and when?
I will specify. As we're getting started, I just want the rough sketches for the time being, okay? Okay, so the domain here goes from -3 to 3.
So they don't go beyond.
Correct. And the range goes from 0 to 3. Because it just stops at the endpoints. It doesn't go past.
Oh, doesn't keep on going like that one.
No.
Wouldn't it be like negative? Oh, because it doesn't go beyond the x. Oh, I see.
Okay?
Just pick 3 to pick 3, right? Like it doesn't-
No. Don't worry about how to graph it by hand. It's 3 because it's the square root of the 9. Later on, in chapter 5, we're gonna learn about this.
Okay.
And then it's gonna be like all you graph.
So the quiz will have a part A, part B.
Uh-huh. Mm-hmm. And listen, if something like this is on a non-calculator part, I'll give you the graph. So the point here is looking at the graph, what is the domain and range, okay? All right. This one too, you can use your calculator. E. This looks like this. I know.
With errors at the end or no?
It's up to you. I don't care for it. I mean, I don't mind.
Oh, but it's implied.
It's implied. Okay, what's the domain here?
Negative 3 to infinity.
Correct. What's the range?
0 to infinity.
What does the next one look like?
Oh, what is that thing? 0? Oh my god.
Uh-huh.
Oh, it's
The flip. The flip. It's like this, but it's flipped.
It's like what, but it's flipped?
It's the thingy.
yeah, isn't it like
It's okay, but it's flipped.
It's the flip of that.
Yeah, it's this. It's this.
Oh.
It's this.
So there is a -1, which means it's moved here. to 1, so it looks like this.
Oh my
Wait, so how do we know if it's that way or the other way?
I'm going to have you use your calculator for this one as well.
You're so nice.
So like,
Okay, what if it's?
What's the domain?
Negative infinity to infinity.
Yeah.
What's the range? Okay.
So this is kind of like our study sheet.
wait, can you go? Can you show? Oh, 1 second.
Y equals x cubed. You have to know how to graph it without a calculator. It's the vertical version of what we just did. X cubed is like this.
Which one are the odd ones?
Down on the left.
This is an odd function.
Yeah, there's this and then that.
This is x cubed. What's the domain and the range? Yep.
I forgot.
I don't mind. Okay, hey guys, I know we're all like, getting, back together and it's exciting, but I don't want to have to talk over your voices, please. Okay. This one, definitely with your calculator. Okay? So there are asymptotes here at 2. Good, very good. There's another one at y equals 0 here.
Why is it got 2 and negative 2?
Because if you put 0.
Set the denominator equal to 0.
Oh, that's
Yeah.
right.
Wait, how do you know where the asymptotes, for example? Because like I put x squared minus 4 equals 0 and I got x equals 2.
And negative 2,
Okay, yeah.
right? The other one,
I always forget that.
the other one, we did it last year. We're gonna do it again this year. It's let's do it again in the next lesson.
The x equals
The horizontal asymptote. Okay.
Leave it on bottom, no?
Oh shit, you're right. No, you're so right.
What is it? What is it?
Leave it on bottom is 0. I'm surprised. Bobo.
No, I joined the class too late.
Okay.
Wait, oh, there's the squiggly thing in the
Do you
middle.
want us to label the asymptotes and all that?
I want you to show them.
Is that like 0.5?
So I don't have to write x equals 2, x equals
No.
Wait, is the problem like Wait, what's the domain?
It's just show that it goes down like this. Okay. Okay. So.
Negative infinity to negative 2.
Comma, negative 2
No, not comma,
to...
you.
I mean you, my bad. And then 2 to infinity.
That's where so is.
But the negative 2 isn't a bracket, right?
No, I used to join.
No, it's a parentheses.
It's like they included.
Yeah.
Yeah, it's really
Okay. Next.
Wait,
Hey guys, chit chat needs to stop now, please. Okay.
Oh, we're not doing the range?
We are. So for the range, we're gonna go from negative infinity to 0, and then 0 to infinity. Okay. We're gonna do more on this in a little bit. Okay?
Is that a calculator one?
Yeah. Okay.
the brackets and the parentheses didn't matter on that one?
No, because
It does. They're all parentheses because there's asymptotes everywhere. Hey, I cannot talk over the voices every single time. Every single time somebody asks this question, I cannot. Come on. Okay. So, okay. Absolute value function. So y equals absolute value of x, right? We've learned that the graph of this looks like this, okay? We learned this in algebra 1 and 2, okay? Now, in calculus, we look at this a different way, okay? Because look, if you just take this, right, that looks like this graph, which is y equals negative x, right? But that happens for all the x's less than 0. So it's like this. It's like negative x for all the x's less than 0. Then if you look at this, that looks like this graph, y equals x, right? So this is the full-fledged y equals x, but if you only take the part from 0 and on, that's that. So putting it together, if you take y equals negative x, only for x's less than 0, and if you take y equals x only for x's greater than 0, that gives you an absolute value function, okay? So that's another way in calculus that we represent absolute value functions. So what's the domain of this, y equals root x? Based on that, what's the domain? Correct. And what's the range? 0 to infinity. This one, the absolute value. Okay? 0 to infinity. Closed. Okay. Let's graph a piecewise function. Okay. So here we go. Looking at this, the first thing my eyes will see is that it's separated, partitioned at what point? X equals what? 0. So if you want to put in, some like helpful lines for you, these are not asymptotes. If you want to like physically put in the border, fine. The more sophisticated we get, the less we do that, right? Because we should be able to do it without. Okay, so now, this function here, each of those you can take as y equals whatever that is. So this is like y equals 3. Okay, what does y equals 3 look like? What graph does that look like? It's a horizontal. It passes through y equals 3, right? So it's a horizontal. Now, at the partition, does this one have an open or a closed circle? Open. So y equals 3. 1, 2, 3 here. And that looks like that. Okay. The next one, this is like y equals root x plus 3. Exactly, it's like this. At the partition, at x equals 0, what value does that have? Just 3. Is it open or closed? Closed. So if you have open and closed on top, what do? Just fill it in, close it. And then let's put in another value, x equals 1. 4. And we know it's a square root, so we make it look like that. It is actually interesting.
And then for these, we don't need to find the domain range.
No, it's not asking you. It's just showing you piecewise functions to graph.
Would we be asked for the domain range?
You might be. What is the domain?
Negative.
Right? And what is the range?
3
to infinity. Piecewise functions are huge in calculus. Because if calculus models real life, which it does, how often do things just stay the same in real life? Never. Things are always changing, and the way to show that is by piecewise functions. Okay, let's try it without those helping lines or helpful lines this time. Let's do it like the grown-up way, okay? All right, so 1 is at x equals 0. So first I'm going to graph this one, y equals x squared. It's a parabola. At x equals 0, what's the value? 0. Open or closed? Open. And then where does this parabola live? Does it live to the right or to the left of this? To the left of this. So to the left, pick a point. Negative 1, put it in there. What's y? 1. So, okay. Now, the next one, y equals x cubed, has two boundary points. One at 0, one at 2. Let's put in x equals 0. What's y? Open or closed? So just close this. Put in the 2. What's y? 8. Open or closed? Closed. So it's like this. This is a cubic function, right? Like it would have gone, like a snake down. And then past that, what kind of function is the other one? What kind of graph does y equals negative x plus 10 produce? A line. Okay. So the boundary is that x is 2. Let's plug in x is 2. What do we get? 8. Open or closed? Open, but that's already closed, right? Open and close on top of each other, it stays closed. So let's put in another point, right? Like let's put in, I don't know, x equals 3 or something. 7. So that looks like this.
Wait, what?
Wait, can you zoom in?
You know what? Instead of, because it's tight over there, why don't we plug in like x equals 5? Let's plug in x equals 5. What do you get? 5. Here. Like that, right?
Oh, so it's 5.
Yeah.
And it would be an open circle, but it's not because of the other.
Correct. So at the 2, this is closed, this is open, and if they, overlap, it's just closed.
Isn't
that
that 5 also open?
Where did you get that other 5 from?
This one?
Yeah.
This one, because it's not a boundary point, it's just like a point on the graph, so there is no open or close, because it's just going to continue. We just did that to fix the orientation of our graph.
The 5, 5.
Since x cubed looks like this thing, why did you draw it like a parabola?
So it would have looked like that. If I was just graphing x cubed, it would have looked like this. Right? But this only lives from 0 to 2, so that's the only part. Uh-huh. Yeah. Of course.
Because it's a closed circle, because it's a greater than or equal to at 2, so then that's 2 is another boundary.
Okay. Piecewise function. I love them. Let's write a formula for this.
What would be the domain and range of this one?
I have not gotten this question.
What would be domain for this? Negative infinity to infinity. What would be range? Negative infinity to infinity, because this goes up and that goes all the way down. So both domain and range are negative to positive infinity. Okay, last but not least, piecewise formula.
Oh, I'm so
Can I try?
Yeah.
Negative infinity.
No, we need the piecewise function. So here's what you do. Okay, f of x equals this part first. What's the equation of this line? Y equals mx plus b. Okay, what's the slope here? 1.
It's negative.
What's b?
No, it's positive.
0. So y equals 1x plus 0. Y equals x.
Wait, but when the m be negative 1?
No, because it's going up.
Because you
It's
always go
rising.
from left to right.
So it's just x.
Okay, this one here is just y equals 2, so you just do 2. Now, this function lives on negative infinity to 0, right? Or all x's less than 0. So this function lives on x is less than 0. And that's a closed circle, so I close this.
Right, yeah.
Okay? This function lives on x's greater than 0. Yeah. Yep. Yep.
Why is the first one n?
Huh?
The top equation. It's like 2.
This one?
Yeah, why is it?
You told me that. Remember y equals mx plus b? M is 1, b is 0.
Why is B
1x plus 0.
It's just
Because
that's
starting-
the
Yeah, because the y-intercept is 0.